From the freezing farthest regions of the Oort cloud to the charbroiled Mercury and Venus, a tour of our solar system displays a startling array of worlds. But there are few possibilities for life beyond our Earth. It may be subterranean Mars or the moons of giant planets with their hidden oceans, but so far, it's just us. Decades ago, science fiction offered a hypothetical scenario. What if alien life were thriving in an ocean beneath the icy surface of Jupiter's moon Europa? Europa and her three large sibling satellites, Io, Ganymede, and Callisto, were discovered by the astronomer Galileo in 1610. Then in the 1960s, ground-based telescope observations determined that Europa's surface composition is mostly water ice, as are most other solid bodies of the outer solar system. The Pioneer 10 and 11 spacecraft flew by Jupiter in the early 1970s, but in 1979 the two Voyager spacecraft passed through the Jovian system, providing the first hints that Europa might contain liquid water. In 1995, Galileo, an American robotic space probe, was sent to examine Europa. On September 29, 2022, Juno spacecraft's most detailed image during its close flyby of Europa, and ground-based telescopes on Earth, along with various robotic spacecrafts, have increased scientists' confidence for Europa. But what is happening beneath the icy surface of Jupiter's moon Europa? Why has NASA planned to send a spacecraft to study the Galilean moon Europa? Is there any possibility of life on Europa? The first closest approach to the Europa was made by Voyager spacecraft. The spacecraft provided the first images close enough to reveal that Europa's surface is crossed by ridges and cracks. Researchers noted some of the dark bands had opposite sides that matched each other extremely well, like pieces of a jigsaw puzzle. These cracks had separated, and dark, icy material appeared to have flowed into the opened gaps, suggesting that the surface had been active at some time in the past. Voyager images showed only a handful of impact craters, which are expected to build up over time as a planetary surface is constantly bombarded by meteorites over billions of years until the surface is covered in craters. Thus, a lack of large impact craters suggested that the moon's surface was relatively young and implied that something had erased them, such as icy, volcanic flows, or settling of the icy crust under its own weight. Just look, here you can see the patterns of some of the longest linear features on the surface. According to scientists, the longest linear features did not fit predicted patterns of fractures that should be created by tides as Europa orbits Jupiter. They determined that the patterns would fit very well if Europa's surface could move independently and was not locked to the rest of the interior, as would be the case if a layer of liquid or slightly warmer ice existed between the crust and deep interior. One of the most important measurements made by the Galileo mission showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within Europa by a deep layer of some electrically conductive fluid beneath the surface. A team led by researchers out of NASA's Goddard Space Flight Center in Greenbelt, Maryland, has confirmed traces of water vapor above the surface of Jupiter's icy moon Europa. Out of 17 observations by the W.M. Keck Observatory in Hawaii, which uses a spectrograph to detect the chemical compositions of other planets' atmospheres by scanning the infrared light they release or absorb, the scientists only spotted water vapor in one. Now look at this image. This is a double ridge M crest on Europa, and this is another double ridge M crest in Greenland on Earth. But, how can the double ridge form? Water is trapped below the solid ice crust under normal conditions. When damage occurs to the ice crust, either on Earth or Europa, the change in pressure within the trapped water causes some of it to move toward any fractures. When this refreezes, small peaks tend to form on the edges of where the water flowed. A proper double ridge can form as water continues to move toward the edges of the original crack, while pressure continues to settle. Recent picture from Juno spacecraft on September 29, 2022, shows Europa's wild, icy, cracked crust in a region near the equator dubbed N Regio. The terrain is rugged and has been repeatedly fractured apart. Slushy ice, perhaps supplied from relatively warmer regions below, may have filled these cracks. And this is why researchers consider, lives may exist beneath the icy surface of Jupiter because life as we know it seems to have three main requirements: liquid water, the appropriate chemical elements, and an energy source. Astrobiologists believe Europa has abundant water and the right chemical elements, but an energy source on Europa has been difficult to confirm. Do you know, on Earth, life forms have been found thriving near subterranean volcanoes, deep-sea vents, and other extreme environments. These extremophile life forms give scientists clues about how life may be able to survive beneath Europa's ice shell.